Hey, I'm Anand Chaudhary, an 8th grader from John F. Kennedy Middle School. And in today's video, I want to briefly go over what a function is and how to define what is a function, what's not a function. So let's get started. So what is a function? A function is any expression where each input, x, because that's usually what an input is, has one specific output, y, because that's what an output usually is, function-wise. So let's try visualizing this first. Let's say I went out fishing one day and I started marking down, and let's say I caught 4 fish, okay? So this is going to be fish, or in other words, x, and this is going to be the fish's weight. So I'll write x and y over here just so you guys understand what the input and the output is. Let's say I caught 4 fish. This is fish number 1, fish number 2, fish number 3, and fish number 4. And they each had different weights. Like this one had 3.7 pounds of weight, and let's say this is an LB's. This one weighed 4.2. This one weighed 1.6 pounds, and this one weighed, let's say this one weighed 6.5 pounds. So one thing that you guys can realize from this is that every input has one output. Now multiple outputs, just one output. And when we're going to go on to these graphs over here, I'll explain a little bit about the vertical line test and how this is going to help you define what a function is. And I'll also make a whole new video on the next video about what the vertical line test is, so you guys can get a better feel for what that is. So anyway, these all have one specific value. So fish number 1 has a weight of 3.7. It doesn't have a weight of 3.7 and 4.5 pounds because you can't have 2 different outputs. Because according to our definition, it has one specific output. Not multiple, just one specific output. So each of these have one specific output. Now one of the things that kind of confuse lots of people is if I were, let's say I changed number 4's weight to 4.2 to match with fish number 2's weight. Would that still be a function? Definitely, it's still a function. It's just there's another test called the horizontal line test which you would fail. But it's still a function because it'll pass the vertical line test, and that too, they all still have one individual output. Like fish number 1 has one output, fish number 2 has one output, fish number 3 has one output, and fish number 4 has one output. Though these two may have the same weight, it's just by chance, let's say, and it is still a function because it does pass the vertical line test. And I'll try briefly going over these. So now we know how to kind of find out whether something is a function by looking at a table, but how would you find out if something's a function by looking at a graph? So let's just think about this. Let's say that this is 1, 2, 3, 4, okay? And we're going to use something called the vertical line test, which I'll go much more into in the next video, but the vertical line test is when you draw straight lines, vertical lines, and make sure that each graph has one individual point. So if you see here, this first point I have, and let's say this is -2, has only one point. It only has this point over here. Second one I have only has this point over here. There should be one over here, so I'll draw one over here. This one only has this, which is the y-intercept because x is equal to 0. This vertical line only has this point, and this vertical line only has this point. So would this be a function? Yes, because each individual point has, each part of the graph only has one, each x value has one and y value as an output. Okay, so this is, yes, it is indeed a function. Now, I'm not going to draw these lines each time, we can try visualizing it. So this seems like it would be a quadratic equation, like x squared plus something. So because this is a quadratic equation, it's a parabola. And if I were to draw vertical lines, it would pass the vertical line test because each x value is going to have one y value. See, if I were to drop down a vertical line here, it's going to have only this point. Now this point and that point is one point. So this does pass that. But one thing I want to quickly go over here is the horizontal line test. if you do the horizontal line test, there are going to be multiple points where it does have the same value. And I'll go over that again more in the next video so that you guys can have a better understanding of it, but let's just for now keep it simple and say yes, this did pass the vertical line test and it is a function. This one will definitely pass because if you were to do the vertical line test, each one is going to have 1 point. And this little area is going to trick people a little bit, but if you do the vertical line test, it's going to only have 1 point, not multiple points. So this one is, yes, it is a function. Now this one is a really tricky one to other people. It's okay, if you were to do the vertical line test, it would pass, but the thing that confuses people the most is when it does have an asymptote. When it does have an asymptote, people are like, oh, doesn't the function need to have a point in every part of the graph? But no, it actually doesn't. It passes the vertical line test because each point only has one, each x value only has one y value. So it does pass, and it doesn't matter, not each point of the graph does not have to exist. Okay, so this does pass the vertical line test. Yes. Now this one on the other hand, this one is basically this function except like flipped a bit and reflected, and it does not pass the vertical line test, so it is not a function. See, if you were to do a vertical line test right over here, it has multiple values. Let's say this will have like this value, multiple values for this same x value. So it does not pass the vertical line test. And so that's kind of how you define a function off graphs. And the way I showed you previously was how you define a function off of a table. The one thing I want to go over quickly about the table, which I did forget to mention, was this. Let's say, because this is kind of going into the path of, does this fish weigh 1.6 pounds and or 2.6 pounds? Let's say I had fish 1, 2, 3, 4, and let's say I have another fish 2, which is the exact same value as that. And it has the weight of 3.5. This cannot happen because now you have two of the same x values which have different y values. So that cannot happen in a function at all. That's kind of like saying it's going to look something like that because it's going to have multiple y values for the same x value. So that's what this video is about. It was like a brief introduction to what a function is, and I hope this helped you guys. And just for the record, we're going to use this a lot in calculus. So I hope you guys understand this more on your own, and hope this video helped you guys just to get a basic on it. And please like and subscribe to the video, and thank you for watching. Bye.